Yeah, welcome to the talk of Michael Meeks about LibreOffice, story of cleaning and refactoring a giant code base. He will have a lot of things to tell us, so he will quite hurry. And if there is enough time in there, if he's quick enough, and then there might be a chance to have to answer some of your questions afterwards. So,
thank you very much. Brilliant. Well, glad you could make it. Here's what I'm going to try and say. My hidden, not so hidden agenda, as Friedrich likes to call it. What I'm going to try and persuade you is that we're doing some crazy fun things in LibreOffice. We're refactoring the code and doing mad things everywhere. And I'm going to try and show you what the impact then is on the quality. Many of you may have suffered in commercial proprietary software companies where there's a very different ethos about actually changing code. And so hopefully we can use some experience here to show that you can do things better. And then I'm going to show you a bit about some of the features in 4.0, if we have time. And that's about it. So, before I start, I really want to talk about culture. I've been reading a very good book called The Wealth and Poverty of Nations, which I strongly recommend. There's a very good book by Jared Diamond called Guns, Germs, and Steel. I don't know if you've heard that. Read that? Yes, very good book. I read that and I was convinced, and now I read Landis, and I'm more convinced by him. So, check it out. But one of his theses is that culture is really, really important. And I think when we write software, we can get confused that free software is about software, and really it's about freedom, and freedom is really how we interact with each other, isn't it? Let's face it. So, actually, the foundation of software is how people relate, and how people relate is really culture. And so I think these two are very closely tied. I'd like to talk about a dead culture. Now, of course, it says at the bottom, okay, I'll talk about that in a minute. So if we look, for example, if you look at Jared Diamond's thesis that geography is the primary cause of Western or supposedly Western dominance, it's interesting then that you look in similar geographical regions, and Japan, for example, was the only East Asian sort of country that industrialized and did a fantastic job of adopting new things. So you look at China, and Ming China had everything. They were the superpower technologically. They were amazing. And they invented everything. It was all invented there. But primarily, they sort of went to other places in order to show them how great they were. Asked for tribute, and here we are. Of course, a different culture today. The West, in these eras, the 18th, 19th century, greedy and rapacious, for sure. Terrible to interact with, but also greedy for new ideas, new ways of doing things. What can we learn? How can we apply it? How can we improve? One of the stories I really like in Landis' book is of people, 200 years ago who couldn't afford a watch. The watch was the technology, the iPad of the day, was a clock. And why is it so cool? Well, because a clock means you can time your life accurately. You can plow your field, and you can do it a different way and see if you do it quicker. And that is exciting. Well, it was exciting in England anyway. And so lots of people would save up money in syndicates to buy clocks so they could not flash them off. I have the latest brand, but so that they could time their life and improve it and make it better. They were greedy for change, greedy for that 1% that you could measure with a clock. And, that innovation and invention of innovation. So, interesting theses. Let's look at, I think, a broken culture, which I've experienced interacting with, and this, again, is slightly unfair. It's a caricature. Lots of individuals I dealt with in this culture were, in fact, very open. But I think it's easy to get to a stage where, change is dangerous, particularly rapid change that we can't control and guide. That things are always better in the past, really we should just go back to then and it'll be great. Process heavy, we must stop people doing things because, this change might be dangerous. It's all got to be done very professionally. You need really permission before you do anything. Very important that, otherwise you might do something bad. And why bother? It's all a bit of a waste. Over-design, under-implement, a problem for every solution. And I don't know if you've interacted with cultures like this, but I think they're pretty terrible to deal with. So LibreOffice, faced with cultures like this, really went for a cultural rupture. Change is mandatory. Without it, we're going to lose. We have to change, whatever it is. We have to be oriented in the future. Let me tell you, LibreOffice's best days are yet to come. We're doing pretty awesomely. I mean, we're doing very well, but really, the true glory is coming, right? So if you want to be part of it, get stuck in now. Inclusion is much more important than outright perfection. We want to get people stuck in into the project and bound in and relating and having fun. We want it to be bad the first time, and then we want to iterate, and we want to do that quickly and get there. And breakage is normal. If you broke something, that's good. You actually tried to change something. Good. Excellent. Fine. Software breaks. That's true. And we have lots of ways, and we'll go through that, of trying to catch and stop breakage, but those are not ways of stopping people changing stuff. They're ways of encouraging people to change stuff and then fixing it more rapidly. And yeah, process this stuff off like you wouldn't believe. Let's try and not get any more and fix what we have. So it should be fun, rewarding, and of course sometimes people do come up with crazy ideas, but there's got to be a really, really good reason for stopping people doing things. Incidentally, do you like my Bluetooth remote control that renders my slides? It's kind of pretty cool. I can see what's coming next. So making it easy and fun to contribute is really cool. So we do that with an easy hacks page. I'm just going to bang through some of these. Lots of small tasks so you can get involved, contribute quickly, and life is good. Open mailing lists, just small details. So in the olden days, we had reply-to mangling. There are religious wars on this. My experience is that if you send an email to a reply-to mangling list, it's very easy for all the inside people on it, because they get the reply that they write back from the mailing list. But if you're not subscribed, you basically don't get a reply. That's pretty much how it goes. And so, well, we don't like that. Just mail your patch in, you're done, interact with us, we're easy, we have a porous boundary at the outside. We wrote documentation to make it easier for people to come in. We have hundreds of README files with structural documentation. We started migrating our comments to Doxygen so we can actually build nice docs. Bjorn deployed Gerrit, and it's awesome. So the problem with Git is, of course, that to get a commit access, you need SSH keys and set up accounts. Gerrit automates this process. You don't have to ask anyone. You can commit to LibreOffice without asking permission at all. So it turns an OpenID, I know OpenID is a bit controversial, OpenID account into a Git commit access, like that, pretty much. And so you can commit, and increasingly we'll be having test build integration, so we can merge patches, but only if they build, Go and automatically merge this, but only if it builds on 10 machines, just to reduce the process overhead and the testing and build breakage. Of course, it's really important that you guys can build things quickly. So we put a lot of effort into tinderboxes. And this nice company, Bytemark, has donated ultra-fast hardware to be building on Windows. We build on Android, Android ARM, x86, and just all the Linux distributions there. If you have a distro you want to package for, why not get a tinderbox machine up and going to make sure it continues to build nicely? What else do we do? Well, we want to make sure that the code is of a high quality. If we're changing so much so quickly, so we use Clang. Now, I'm not a big fan of Clang because it's not GCC and it's not GPL. But that aside, it's a very good compiler, and it has all sorts of custom compilation verification things. So we can add checks that introspect method calls and check the arguments are right. So in this case, there are only a few strings that you're allowed to put out at the front, bridges.ios, in some random function call. Well, that's checked by our tinderboxes every time you commit. Or, checking for white space violations that look like they could be a bug, right? Tinderbox dies, someone goes and fixes it, and it probably was a mistake. So, reducing the scope for those manual mistakes is really, really helpful to accelerate the pace of change. So there we go, making the code readable. Well, one of our problems was having an obsolete, manually patched, horrible build infrastructure. And so there was some transition underway at the time we got the code, but we've accelerated that and driven it almost to completion. We can now build something like 10,000 modules wide. So if you have a 10,000 CPU machine, and you want to run a very slow C++ compiler on every node at once and test it, then we can help you there. That's great. And all of these wonderful people and volunteers have been helping that, and it helps library merging, makes us run quicker. Who speaks German here? Hey, so you have a special ministry. You have nature has endowed you with a wonderful gift, And I always say that I feel bad saying this as an English person. But let me tell you, I've just been on a world tour, and I went to Saudi Arabia, and they complained about the German comments. And I went to Beijing, and they complained about the German comments. And they said, please, the code is no easier when you can't understand it. So either way, we've made a great change here, and of course, it really helps get people into the code. 20,000 lines. If you go to the LibreOffice developer stand, they will give you a USB key with our entire Git tree on it, so you don't have to check it out. You don't need to compile it, just translate, If we all did 100 comments, it would be done, and the code would be more accessible by many people. Other things, so these are some of the kinds of refactorings that we're doing. We had 4 string classes. We managed to kill 1. Quailon did a wonderful job writing it out. We're getting the second one well on its way out. Many modules completely cleaned up, but just lots of code churn. Lots and lots of code churn getting rid of these things. Changing prefixes, someone in the past thought it would be great to have RTL, const, ASCII, string, param in front of every string, literal that you typed in the code. So, we fixed that, improved it, templatized it, done massive code changes to change all of this sort of stuff. Great work happening there. I think the bottom of this patch is much more readable. And it's actually quicker in many instances due to the magic of some of the things we do. Other cleanup, CPP check. We thought we'd run some lint tooling. Isn't that good? 1,000 patches or so with CPP check in the Git commit things. Some great work happening there. Dead code removal, ripping out code we know is never used. There's lots more to go, but that's kind of cool. Another thing that hasn't happened in the code base, again, that churns the code and doesn't really add new features, but adds potential breakage, but makes it aesthetically nice, is using some of these cool new technologies inside our component model that actually add runtime type checking. So instead of passing strings all over the place to talk about components, you pass a checked actual name that's compiled in. So some great things there being deployed everywhere. One of the most risky, and potentially, if you look at the regressions, we got a lot of regressions from this, but it was really important. LibreOffice the code base dates from before templates were invented. So the very early eras of C++, some of the code comes from, and we still had loads of it. 20-year-old code using these macros. And it worked. There was nothing wrong with it. It did seem to work. And we ripped all of that out, and we put STL code in instead that's nominally standard, easier to read. And that showed us that, in fact, the code that was appearing to work in many corner cases didn't. And STL, luckily, is more crashy in these cases and has checking iterators. But yeah, we ripped out loads of obsolete classes, and yeah, we did gratuitous code change all over the place. We threw away libraries that had been obsolete for years. LibVos, when I started on OpenOffice in 2000, before it was open sourced, this library was obsolete. It's been obsolete for the whole lifetime of OpenOffice and LibreOffice. And finally, we've got rid of it. Again, rewriting chunks of code everywhere. White space cleanup. There was just a total mess, depending on what editor you used. We fixed that. The Windows installer we completely rewrote, away from NSys, which is, well, it's good at what it does, but having MSI files inside NSys was not good. Completely radically changing the translation mechanism to not use a horrible proprietary SDF standard instead. Language tags, touching almost everything that goes with language to add a much more powerful BCP47 compatible language system so we can deal with Serbian, for example, which is in either Cyrillic or Latin, same language, same locale, different rendering. VCL, yeah, substantially refactored, so we have a headless version. So if you have a document management system now, you can run the thing completely headless, and that's nicely factored out, and you can select it at runtime. And hey, the GTK3 port came in there, some great work. The wizards being rewritten from Java to Python. Again, a language change. It has some nice impact on Windows, where we don't know that Java is there. But again, significant change. I'm just going to go through, this is kind of a joke slide, next slide to wake you up. But I just talk about a few things here, a bit more big refactorings before we get to the statistics on the impact of all of this. So many decades ago, Marco Borries, a wonderful programmer, sat in his shed and decided to create a wonderful object-oriented toolkit. And as we all know, object orientation solves every programming problem, and it's going to revolutionize everything. Anyway. Then he wrote some demo applications to show off his toolkit. Fast forward 25 years, and those demo apps are now LibreOffice. And so many key architectural considerations were made with a full understanding of scalability, internationalization, all of the things, obviously, because, they were just going to be demo apps. Anyhow, so there are lots of refactoring that's going on. And don't get me wrong, lots of things have been improved since then. It's a great product. But you can still see echoes of some of those early decisions. Later on, the company got very large, and there was a sort of architect-driven cargo cult of component technology. And whatever you did, it had to be componentized. So Uno was the wonderful thing, and just all of these galloping inefficiencies were introduced, terrible, terrible side effects of using a good technology for the wrong things. So yes, I mean, I list some of the problems there. Here are some of the larger refactorings we're doing. So in part, exacerbated by component technology, people would just go and duplicate loads of stuff. So yeah, import, for example, the domain mapper was written, and initially we had, although the file formats are broadly the same, .doc, .rtf, and .docx, initially the RTF filter was essentially a cut and paste of the doc filter with a whole load of changes to it. They literally cut and pasted one of the most important core pieces of the suite. Well, that was not very good. They then went on to create an artificial barrier between docx and .doc by saying, well, we're going to rewrite everything in a new way using component technology. So then there were 3 filters for these 3 almost identical file formats using different technologies and different code bases. So, and similarly in export, and we came along, we basically said, this is madness, we're going to share all of this code. And so since we wrote the export, we didn't have this crazy stuff. It's all shared in the core now, which is great. So hopefully when you fix a .doc export bug, it's trivial to fix the RTF and docx bug. On the import side, we've managed to unify RTF and docx, which is great. There's ongoing work, well, thinking about unifying these two is, again, a huge engineering problem. And we need to bring the docx support up in terms of quality. But just loads of change there, just to make it more maintainable. You know, I mean, we could have fixed bugs in 3 places every time, but it just doesn't make sense. Similarly, RTF is used for cut and paste. So on Windows, when you do cut and paste, it's all RTF going from A to B. So again, large-scale changes to make all that work better. Calc refactoring, we've just done so much inside the spreadsheet. And there's so much left to do. Saving wastage, reducing structure sizes, reworking note storage, improving performance orders, removing excessive component usage that's not necessary, new data structures for core functionality, reducing memory space, and so on. So really large changes to the code base. And in many cases done by Kohei and Marcus, who's a wonderful volunteer that works with us. And just significant change. What else are we doing? Well, that's the stuff that's done, I guess. More stuff we're continuing doing is changing all of the UI. So the UI uses a terrible legacy toolkit that was deliberately designed not to use layout. And finally, we're using layout. Wonderful, isn't it? So, Java Swing got this right in 95, or maybe 96. And yeah, but we're just catching up. So that's great. Thanks to Quaylon. And that's really good for translation. And it's really good for having a clean, small, abstract description of your UI. 100 dialogues so far, another 400 to go. If you want to get involved, get stuck in. It's some easy work that's really useful. It improves accessibility as well. But again, another huge, widespread refactoring of the code base. What else? Well, VCL has some real problems. No, there's no lifecycle handling. You allocate windows and free them, which is fine until you have idle callbacks and multiple threads and other ways of handling lifecycle which don't work terribly well. A writer has debilitating problems from its big pointer array, which is surprisingly a big array of pointers. And, and would you believe it? When you do redlining in a document, and it's the visibility of the redlining is not on, it actually copies and pastes all the redlining into and out of the document for every keystroke. Yeah. And so there's this wonderful dialogue that pops up when your document gets a bit big in this mode saying, you do realize we can't cope. It's going to get very slow at this stage. And so either way, we're improving some of these structures underneath. So typing at the beginning of a vast document should be just as fast as in the middle or the end. Code cleanliness reworking, huge automated changes coming for 4.02 to make the code more readable, small, and so on. So an important part, and what I'm trying to get over, is that there should be no-go areas. Sure, we change something, sure, it breaks something, and that's a great way of finding where the bad areas are in a very overcoupled code base. We need to find those things, and hey, we'll back it out if it's a problem. Hopefully that will never get to you as a user, because we'll see it in our unit tests, and we'll see it in our user testing. But it's important to change the code. So Lubosh, here, look at the man. Wonderful, wonderful. Lots of auto-generated patching, for big bulk changes, and we need some help there. There are some security bugs that hide behind stream operators that don't behave quite as you'd expect. And again, hopefully we'll get a lot of those fixed. He's written a very nice tutorial on how to write plugins for Clang there, again with a Clang caveat, to allow you to do big refactorings. You know, Eclipse has done this, or NetBeans, I'm sure, for Java for years, you know, because the Java IDEs parse and understand Java. But of course, that hasn't really been true for C and C++, but it's starting to be true. So if you have a huge legacy code base, I'd really encourage you to start looking at, you know, some of these things, because they can really help improve factoring. Well, how can you do that while retaining quality, you know? How can you do it? Well, the first radical idea, and this is really radical, is to have unit tests. I know, I'm glad. So actually, it turned out that one of the problems of our complicated reuse infrastructure that no one uses is that it makes it very hard to write unit tests. So we did a load of work to actually make it possible to write the first unit test. You know, that would start LibreOffice and do a whole load of work, and then check the result. And then there were loads of them. People just went a bit wild. And in the end, they produced generic infrastructures for testing thousands of documents. In fact, Marcus is now working on, you know, having a tinderbox that loads thousands of bug documents and checks that they're still working, you know, as we go along, which is cool. So, you know, if you have lots of hardware, you want to donate to, you know, heavy-duty testing, that would be cool. One of the interesting things we found, having created the unit test framework, was we dropped all the CVE bug documents we'd had, all the security bugs for the last 10 years in. Half of them had regressed. So they were fixed. You know, this was long ago now, so luckily you're all protected, but there you go. If you ever want to find a security bug in a piece of software, I'd strongly recommend going back to the previous CVEs. Anyhow, what else? Well, we want to find out about bugs quickly from users. So the Bugzilla Assistant was written by Loic and Rob Snelders, and that allows you then, as an end user, to use Bugzilla without a sort of training course. And, you know, scrolling the scroll bar to find the one field among 50 that's actually interesting to you. And we're also eager, because we have a lot of end users, as opposed to sort of hacker types like yourself, for whom every bug is screamingly important. And, you know, everything is high priority and high severity and whatever, to try and automate the process of doing that. So one of these things, for example, a last known working version, will tag a bug as a regression. That seemed like a good idea. It turns out people just enter random rubbish in there, but at least we're better at filtering that out now. So this really helps us get feedback quickly. Of course, we release early and release often. Every month there's a release. People are often doing sometimes 2 builds in a week to do a release, depending on how the schedule goes. And we're time-based. So we release on time, in time, every time. At least that's the hope. We now do it on a sort of week window rather than a day, but you know, it's possible. GNOME manages to get it to the hour or the minute, so I think we can probably do better. So that's good. By bisection. So another very, very powerful tool. So building LibreOffice takes around 4 hours, or maybe about 15 minutes, but only if you have very fast hardware. So bisecting a bug, a regression bug, is really, really hard. So Bjorn had this fantastic idea of checking all of these binaries that are pre-built into a single Git repository and packing them up. So you can now grab a Git repository that has several thousand builds in it, and you can run git bisect on it. And the checkout time is, you know, a few seconds, and they're completely relocatable, so you can run it from anywhere. And so you can get down to about 10 patches that caused any regression that you can test for. And you can do it in about, well, 10 minutes or less. And you can do it with no skill, you know. If you can use a command line, you can do this. And as a user, that's really, really helpful for us. As a developer, it's fantastic. If you want your bug fixed, and it's a regression, if you do this, your bug will be fixed much quicker, because we can find the lines of code that did it really fast. So that's really cool. And a great tool. And so you know, when you get a tool like this, do you use it to increase quality, or do you use it to increase the pace of change? Well, we tend to go for the pace of change. So same debugging with GDB. So GDB is a nightmare. With the weird strings we use, you couldn't see the strings in the stack trace. So you would never see that this was a path to this. So again, Tom Tromey has done some fantastic work at Red Hat around Python to allow GDB to do amazing things. And we've written some pretty cool introspection stuff. So your GDB stack trace actually shows you what you want to see, and you can do some very, very powerful things with it. A huge improvement to debugging speed, you know, bringing us up to the Visual Studio level on Linux, hopefully. And then, of course, there's manual QA, and some great work done by these guys. You know, triaging incoming bugs, resolving duplicates, tagging the most annoying bugs, or what we think of as the very serious ones, running master builds and reporting bugs early so they're never seen by users and so on. So it's a great thing to get involved with. I really encourage you to do that. But does it work? What is the net outcome? Can you really go away and loose a whole load of untrained volunteers, some of whom have not programmed in anger before, on a 5 million line, highly coupled, poorly architected, code base that's in use by millions of people? Well, can you do that without, something dreadful happening? Well, one of the things that we do is we measure, pretty regularly what's going on. So, do you know that if you want to save energy in your home, you want to save in the environment or whatever, one of the most effective ways, in fact, arguably the most effective way to save energy, is not to insulate your roof or to lag your tank or anything like that. It's just to draw a graph of your energy use. That process in itself saves just, all the other things follow from that. Anyhow, on this basis, we started graphing our regression bugs, and this is what they look like. And I'd like to persuade you that this line is broadly flat. Okay, so it is lower here, I agree. But, after we started graphing it, it kind of flattens out. Now, it goes up here a little bit. Interestingly, it goes up here. This is where we added the feature to tag regressions automatically in the end-user Bugzilla thing. And there was kind of a bug in that tagged a lot. But you notice, actually, we've got more regressions. These are the fixed ones, and these are the open ones. Actually, this went up and then plateaued again. But this thing, we actually fixed a load of these apparently regression bugs much more quickly, which is kind of cool. Anyway, so I'm arguing that this shows a relatively static regression count. It's hard not to regress when you change the code aggressively. Many of these regressions, may not have hit end users either. So, don't get the impression you download it and it'll be terrible. But there's clearly a case that if you download the 0.0 release, and interestingly, we release next week, you will see more bugs than if you download the 0.1 or 0.2 release. So that's normal. But I'd argue that that's broadly flat. Now, why that is, I don't know. But here we go. These are more numbers. We get something like, 1,600 commits a month, something like 50 commits a day. And we've had about 450 regressions last month. So when you do the maths, about 2.5 a day. And since the line is flat, we're fixing about 2.5 a day as well. So if there is one regression caused by, if a commit could only either cause a regression, one of them, or not, that's only 5% of commits that cause a regression. So I'd argue, in fact, that some of them cause several. So actually, it's probably lower than that. And many are fixed before we ship. It would be great to do more research on escaped regressions. If someone wants to do that would be. But I would argue that some are inevitable. That's just the world we live in. Software has bugs. And of course, we try and, even one is too many, of course. But cost-benefit-wise, we really want to encourage people to change and improve the code base and not be overly conservative. If you look at most annoying bugs, interesting, the graph is remarkably similar. The big hump in it is where someone decided that his whole families of bugs should be high prioritized and so on. Turns out they're actually not that relevant. But this again is flat. And so I think there's a social engineering problem here, that just by showing the graph to people, there is a sort of a limit of most annoying bugs that people will accept. And they fix them until they reach that limit, and then they stop, or something. I mean, I don't know. I don't know why it should be constant like that, but there you are. That's how it goes. Here is a crazy picture of a multivariate space. If you're trying to aim for quality, how do you get there? What do you do? It's totally mad, this drawing. If you're not going to understand it. But I think over at one side here, we have a very slow process model. If you're thinking of the Solaris kernel or whatever, with the 18-month freeze, before you release. I think that's probably at one extreme of it. And it's possible that if you have an 18-month freeze, that you can get a more stable kernel. I don't disagree that might be possible. But I think from a community perspective, there is a limited number of people wanting to work inside this model. Of course, as you shrink the freeze window down here, so it's only a 6-month freeze or whatever, your quality is going to go down, right? So the question is, how do you jump from over here to over here, where suddenly everything is a high speed, lots of change, low process, rapid iteration of releases to try and improve quality? And, well, there you go. I mean, the hope is that, of course, we end up here and the bugs are fixed absolutely immediately and no one even sees them. We're even hoping to fix them inside the programmers before they commit, but that turns out to be difficult. And actually, what most end users get, if you're paying for a SUSE release on Windows or whatever, of course, we use this model and we climb as high as we can up this cliff. And then we switch to a very slow release, very low change, conservative model on top of what the community has built with their wonderful work. And so we hope to get the best of both worlds for our enterprise customers. Just a gratuitous plug. Why not? So since we have all of this ability to try and catch regressions, fix them, and to keep quality in an acceptable level whilst doing huge change, and I've just showed you some of the changes that are really cosmetic in the code, that are really important structurally, but perhaps you don't see. It's hard to show you graphs of performance fixes. I'd just like to give you a few snapshots of some of the features that we've done, and these are really partial. I can only just select a few slides. I don't have a whole load of time. So core interoperability work, and one of the nice things around LibreOffice is that it's very diverse. There are lots of companies involved. In some cases, the Open Source Business Alliance have funded us. Groups of government got together to fund development work, which is going well. So improving interoperability there for Word documents and commenting. I particularly like this. This is a great example of RTF import filter improvements. So the document in LibreOffice 3.6 and the document in LibreOffice 4.0. Looks a bit better, doesn't it? I think there are a lot of, and this is a pattern that's repeated again and again, smarter. I could show you hundreds of these. We're getting better. One I particularly liked, well, importing formulae in RTF is nice. Do you know the meme? Well, hey, Miklo. So, thank you. So you know the idea that as soon as a normal person reads a formula in a book, they stop reading. Well, luckily, our code actually had a great feature whereby it would throw away the rest of the document as soon as the first formula was hit, which is a great feature. We fixed that in recent versions. Another thing here done by another part of the ecosystem, Lanido, making e-ink, from your tablet come in nicely, kind of cool. Some people are a bit foolish and they build their company and the software infrastructure around proprietary software. And that, of course, is a particular problem when you're tying the client to the server. Really, really a foolish thing to do, particularly if the server is running SharePoint. So anyhow, we've done a whole load of work to make it possible to integrate with SharePoint, and unfortunately, you can't fly under the radar at the moment. You have to turn stuff on the server, but we hopefully will work on that in the future. But preferably Alfresco, Nexo, lots of other content management systems using the CMIS open protocol. Another thing we love to do is improve interoperability and drag documents from old binary proprietary formats into the new world of beautiful goodness in ODF. And so we've done work with WordPerfect, Works, CorelDRAW, and so on. New in 4.0 is a Microsoft Publisher import. So we would love to encourage people to use free software instead for their publisher needs. Of course, Draw needs extension. It needs new features to make document layout and so on better. But we think one of the first steps there is getting the documents in, getting people's data in, and then providing the need to improve that and make that better. So yeah, thanks to Brennan doing that. Visio, we managed to, Frederick, reverse engineer all of the Visio file formats from the very first release, 1.0 or whatever, up to the only just released last week, Visio 2013 format. So we should import all of those and stencils too now, which is kind of encouraging. Calc. Yeah, let me just pick one component and look at calc. Well, so there's a whole load of XML mapping. So in the Microsoft world, you're always able to map an XML file to a spreadsheet. So you can drag it in and stick elements and attributes in cells and so on. And so there's a nice new UI to do that. Ongoing work, pretty flags and markers to allow teachers to fail lots of students at once. You look for the row of red flags, and here's the one that that needs the remedial treatment or whatever, which is great. Unfortunately, or fortunately, I think it's a good thing, SUSE was acquired by Attachmate, which is a privately held company. So I no longer have stock options. On the other hand, maybe you do, and so you can now price them and model them and see how rich or otherwise you're going to become. So that's very useful. Some fun stuff. Well, you'll notice you probably can see the very small screen here, and as I slide it across, I get a different slide, which is kind of nice. So you can use your smartphone, which you paid hundreds of euros for and are wondering why it doesn't do anything, to advance your slides at a distance, which is kind of cool. Well, thank you. And there's some potential future work that would be really cool there. So, for example, those laser pointer things? Well, there's an accelerometer in this. I should be able to point at the screen, shouldn't I? And get a moire effect, GL, pixel shaded, beautiful laser pointer, right? So come and see me later if you want to volunteer, for that. So So that's kind of cool. Logo integration, absolutely critical. We should all be programming in Logo, it turns out. Well, one of the good things about this is, A, it's tiny, and B, that in some countries there are legislative reasons that you have to train children in computer science, which is good. We want children not to be using just a word processor to hammer documents out. That is a lame way to teach IT. Of course, everybody has the word processor there, and they do actually have to teach that. So wouldn't it be great if the word processor had a programming language in it that you could teach the basics of programming to people easily with, and reference documents that lead you through stuff, and you get a beautiful document out of it, and you can print it out. That's really important, you know. Print out and take home your program, you know. So, you know. So anyway, there's some beautiful things that have been done there by Laszlo. It's fantastic. I'd really encourage you to look at that if you're in education. UI improvements. Well, we're trying to look less awful. So one of the things was that the image interpolation algorithms that we have will really, you know, sort of guess a pixel, you know, random. And now they're, well, singular crawls, whatever. You can do various improved algorithms to scale your images. They look a lot better. And similarly, you can crunch them down. You know, there's a fad in the world now of having gigapixel cameras. And the problem with the gigapixel camera is you press take photo, and suddenly you have to switch out your SD card for another one to get the other half of the photo on it. And then, you know, you have to sort of crunch for hours to scale it down to the 1 megapixel screen, or actually 0.7 that you're enjoying at the moment. And so, you know, we thought we ought to do something about this. You can right-click your image and scale it down. If you like right to left, you know, in the Arabic world, many Indian languages, we fixed just loads of bugs. You know, early objects that drag the wrong way when you drag them, problems in Calc, new numbering styles. The presenter console is just completely mangled in right to left. New template selection UI, style previews and drop-downs. So anything we can do to stop you pressing the bold button is a good thing, right? So, you know, previewing the styles here, you know. Well, so we're trying. So thanks to Candy for that. Layout, I talked about earlier. A Unity menu integration. If you use Unity, you can get all of that in your taskbar and the awesome bar. And if you don't have that, well, you can have personas, which make you look pretty, you know. So you can personalize it to have birds in the title, which is just great. So here we are. My conclusions are, LibreOffice is really continuing to grow. It's executing. We're starting to pay down these decades of technical debt that we have in a code base that should be clean and beautiful and something we can all be proud of and show to other people. And we're doing it quickly. We're adding features and functions. We're refactoring at speed. And we're trying to accelerate that change with sharp tools and good QA without reducing regressions, so that we can encourage new contributors to get involved and make a real difference to our millions of users. So if you're interested in getting involved, come and see me, come and see the booth at the end. And thank you for your support. LibreOffice would be nothing without all of you guys backing us wholeheartedly, so I want to thank you for that. And that's my talk. So I think we have 10 minutes for questions. Is that right? While you're just doing a microphone thing, I will just show you quickly the Android port, because I quite like that, and it's over here. And it's not really part of my talk, so it's just a gratuitous, you know, plug. But if you like to work on Android, you know, why don't you come and hack with us and work out. And so, you know, loading ODF documents on Android has traditionally been problematic, and so here is one. So there you go. Important, hey? And there's the next page. Anyhow, I digress. Question, where are we?
Okay, well, I don't really have a question. I just wanted to tell you that I believe a lot of people realize that LibreOffice community is doing an amazing job. So just kudos.
Thank you so much.
Done.
Well, it's really not me, I can tell you. There are just hundreds of people involved and excited and doing good things. So thank you. Any other easy questions, you know? Usually they're like, so why do you suck so much? You know, so I appreciate the, you know, that's very kind.
Are there any plans to replace the custom graphics toolkit with something more standard, or do you plan to carry it forward?
Yeah, so that's a really good question about the graphics toolkit. So the plan currently, and you see what Quaylon's done there, is to use Glade, which is the GNOME GTK UI designer. But actually, we're using that on top of VCL. So it's the same old VCL widgets underneath. And there's some really interesting logic underneath VCL. You know, we dynamically detect your desktop. We load, you know, KDE3 or KDE4 or GTK2 or GTK3 or RAWX, depending on what's on your system. So there's some really funky logic there to try and match exactly what you want on your system and make it work well. Currently, there are no plans to change that. So there is a lot of work needed in VCL, but just plugging and replacing an entire new toolkit is, yeah, I mean, that's one of the things we would probably ask you to rethink. Much as we like dynamic change everywhere, I think that is, there really are a lot of dialogues that would need work and lots of code tied to it. So, maybe we'll do it in a branch if you want to get involved, Any other questions? Aha, at the back.
When you switched to the STL, did you have trouble dealing with exceptions, or?
I'm sorry, I didn't hear. When we switched to
Using the STL over...
Yep.
Do you have trouble dealing with C++ exceptions, or were you using those already?
Races. So actually, usually,
exceptions.
Yeah, it's a good question. So is it exception-safe STL? We didn't notice any particular new problems there around exceptions. What we tended to notice was that the previous containers used integer indexes, which are really robust, and they didn't care if you were off the end of the list or off the beginning of the list. You could access the array anywhere and get something that looked sensible. And so, when the code was recursing and doing something and modifying the parent container, it would sort of work. Of course, you might lose elements in the list or double do something to them, but, you didn't crash. So nowadays, we would tend to crash and fix the underlying bug as a result of that, and I think that's a positive change. So I don't know if that answered the question, but it was related. Someone else? There was someone closer to in the middle here. Go for it.
Hello. So you said that you have a huge code base. Mm-hmm. How do you find duplicate in this huge amount of code?
How do you find duplicate code in that? Well, we would love to help find duplicate code more easily. There is, in fact, an easy hack open to use 6gil, I think, which is a static duplicate code finder. Currently, we kind of know where duplicate code is. So in terms of these big chunks of filter, after you've fixed one bug in each of the areas and gone, wait a minute, this code is remarkably similar. It's doing the same thing on the similar format, then you kind of get used to the fact that there's a big problem here that's been created and you need to fix it. So, but yeah, I mean, more formal ways to find duplicate code would be appreciated. If you have some good tools, we'd love to apply them and rip it out, because that'd be cool, yeah. So.
What was stopping trivial changes such as translating comments? Was it copyright assignment?
With copyright assignment, we don't have any copyright assignment. We use uniform.
What was stopping these changes in OpenOffice? I mean, translating comments sounds like a no-brainer.
It sounds like a...
No-brainer.
A no-brainer.
Just go and do it.
Oh,
what was stopping it?
So why are they still there 10 years after it was open sourced? Yes, it's a good question. And I would argue that barriers to entry, very conservative. I think it's a cultural problem.
Copyright assignment.
Yeah, copyright assignment, I think, is a sort of outflow of the concern about change and control. So I think it's probably a symptom, copyright consignment. I mean, it's a big symptom, but yeah, I think it's a symptom of a cultural issue. So yeah, we fixed that. We don't have that problem. And so, just come and get involved. It's easy. Man at the back there. The lady is proxying it. Sorry, Vincent.
Here, and then I'll come over to
Oh, no?
Oh, okay. Sorry.
Go for it. You're holding the mic, no?
I don't know if I'm the only one, but I would love to see peace between LibreOffice and Apache OpenOffice. Is that in the works, or?
Well, I think there are lots of opportunities for code sharing there. We provide code under a license that Apache can incorporate into their binary releases, at least. So I think there's a lot of scope for that. And, you'd have to go and ask them. I think, I'm really interested in talking so much about that. I might say something rude. Lady in orange should be.
So in LibreOffice, text layout has some modern features missing, like automatic ligatures and subpixel positioning.
Okay.
Is fixing that more of an issue of needing someone to do that, or is that an issue of compatibility with documents that expect legacy text layout?
Yeah, that's a really good question. And I'm glad you asked that because I don't know the answer. I'm not infallible. So there is a large degree of glyph substitution. So if you do ligatures now, they should just work. Your TI, whatever, should be a different glyph when you render it, as I understand it. Obviously, typography is something that's always improving, and we can do more work. But if you want to contribute and make it lay out beautifully, as you want, then we'd love that. I mean, help is always appreciated. So yeah, get stuck in. I mean, there's a lot of interesting complex text layout. I don't know if you've seen the graphite fonts for all the really advanced languages, and there's a lot of work we need to do in the core there for cursor, traversal, and there's some really interesting problems with complex text. So yeah, come and see me, get involved.
If I would like to extend LibreOffice, what do you recommend? Really hacking the core or writing a plugin?
That's a really good question. So in the past, the conservative philosophy would say you should write an Uno extension. I think I would want to go entirely the opposite way and say put it in the core, simply because it turns out to be easier to hack the core directly rather than go through a tangled, overly abstract interface that probably doesn't help you. So of course, it depends what you want. If it's going to be an engine control system for your Porsche through calc, not many people have Porsches. So I think it would be, and it's a gigabyte large, then we might have a problem putting it in the core. But if it's small and generally useful, then yeah, I really encourage you to do it in the core. I think that's the best place for it. Are we nearly out of time? What's the...
Still, I think 2 or 3 minutes left.
2 or 3 minutes. So we can take another few questions if you really want. Otherwise, we can let Vincent get on. Let me encourage you. My good friend Vincent is going to speak about GNOME 3 later, and as a GNOME lover, I'm eager to be there. So let me recommend that to you. But hey, thank you so much for your time. Have a great day.
Thank you very much.